This stuff is called disappearing ink. You might have seen it before in a grocery store checkout line, or maybe you learned about it in a more unfortunate manner, like my girlfriend Abby here.
Darn it!
But as you can probably tell by how she didn't kill me yet, the effect is only temporary. Now let me explain to you how it works. Using common mixtures I found online, this 1 ounce bottle of disappearing ink should contain about 0.3 grams of thymolphthalein indicator, 26.1 milliliters of H2O, 2.9 milliliters of ethyl alcohol, and about 0.3 milliliters of 3 molar sodium hydroxide. It is also useful for us to know that this indicator is useful in the range of 9.3 to 10.5 on the pH indicator scale and shows blue above 10.5 and shows clear whenever it's experiencing a more acidic situation. Now that we know this, I will explain why it transitions from dark blue to clear. We know that the original pH is above 10.5 because the pH indicator shows blue. Now to calculate a more exact pH measurement, we know that sodium hydroxide's concentration is about 0.01 molar in the solution, and we know that as a strong base, it will dissociate completely in water. So, because of that, we are able to take the negative log of the OH value, which is the same as the molarity of the sodium hydroxide, and subtract the negative log from 14, which yields a pH value of 12.01, which is in fact above 10.5. Once this solution is exposed to open air, the water from the solution reacts with CO2 to form carbonic acid. This carbonic acid is enough to push the basic form of the indicator back to its slightly acidic form. Once this indicator and the basic indicator reach equilibrium, this Ka expression can be seen. Since we know that the color change for this indicator occurs at a pH of 9.3, we can find the Ka and the concentration of H3O plus at equilibrium. To do this, we know that the equation for pH is the negative log of Ka, and so to reverse this, we can use 10 to the negative pH equals Ka. So in this case, 10 to the negative 9.3 is equal to the Ka at equilibrium, which is equal to the concentration of H3O plus, which is 5.012 times 10 to the negative 10. Thank you for watching, and now you know the science behind this classic prank.